Section 3.8 Inverses and Radical Functions. In this section, you will find the inverse of a polynomial function and restrict the domain to find the inverse of a polynomial function. Okay, let's start. Finding inverses of polynomial functions. So let's review this. How to find the inverse of a function. Example 1, f of x equals 5x cubed plus 1. So remember, every time you get the inverse of a function, the first thing that you do is you can rewrite this as y equals 5x cubed plus 1 and then switch x and y. So take note of that. We did this last time. So switch x and y. So y becomes x and then x becomes y. And then after you switch x and y, you isolate y. Solve for y. So subtract 1, x minus 1 is equal to 5y cubed, then divide both sides by 5, and then last step is to get rid of cube, meaning cube root both sides. So the inverse of y is cube root of x minus 1 over 5. And take a look at this graphical view of the given function and its inverse. This is 5x cubed plus 1. A cubic shape is like this, like an S. And the transformation is plus 1, so meaning you go up 1. So that's why you have here a point at 0, 1. So this is your graph and vertically stretched since your stretch factor is 5. And the other graph here is the inverse. This is cube root of x minus 1 over 5. And if you notice here, if you have the dotted lines here, which is y equals x, meaning your given function, the blue graph, when you reflect it across the y equals x, it's going to be this inverse graph, the red one. Always. Any type of graph, if you reflect it across the y equals x, that's going to be the inverse graph. That's the easiest way if you want to do that. Okay. Also, since take note of this, we always switch x and y when you solve for an inverse. So that's why pay attention to the points of the given function f of x, 0, 1. So this is your x and this is your y. When you switch these two, that becomes y 0, 1, 0. So this is your x and y. You switch x and y, switch 0 and 1, so that's why you have 1, 0. Same thing here. If you have 1, 6, this is your xy, switch x and y, that's why you have now 6 and 1. So those are the inverses. Okay, next is restricting domain. Say we wanted to find the inverse of y equals 1/2 x squared. How would we do it? So the first one is we solve for the inverse. So remember, switch x and y. So I'm going to write it here so we have a space. So y becomes x 1/2 y squared. And then isolate y, solve for y. So first you can multiply both sides by 2. So this is now 2x is equal to y squared. To get rid of 2, you square with both sides, so that you're going to have y, which is the inverse, is equal to square root of 2x is plus or minus 2x. Okay, and if we graph this, think about square root of 2x is this graph. Negative square root of 2x is this part here. Okay, so again, this is the inverse of y equals 1/2 x squared. Okay, so the key thing about finding the inverses with a polynomial is that we must restrict the domain to make the function 1-to-1. So how do we do that with this example? So we can just take the positive of it and we can remove this part here. Now this is just the part of positive square root of 2x. Now this graph here is a 1-to-1 function. Okay, so and that is what we're going to do for the next problem. We are restricting the domain. Oops. Then find the inverse of f of x equals x minus 2 squared minus 3. Let's try to graph this. What are the transformations here? Minus 2 meaning that is right 2, and minus 3 meaning down 3. So let's do that. Right 2 and down 3. So that is a parabola, so you can have a parabola like this. But now we are restricting the domain. So let's just use the positive side here. So we're gonna erase this part here. So we want to get the inverse of this. Okay, so let's do that. So f of x, that's equal to y equals x minus 2 squared minus 3. Then switch x and y. So x is equal to y minus 2 squared minus 3. Solve for y. So add 3. X plus 3 equals y minus 2 squared. Then to get rid of squared, square root both sides. Now this is y minus 2. Now square root of this is positive, negative. Since we're only using the positive side, so we're just going to use the positive, not including the negative. So that's what means by restricting the domain. So we want this side only of the parabola, so the positive side. And then the last one is add 2. So our inverse is going to be, I'm going to write down here, is 2 plus square root of x plus 3. So if you are going to graph this, what are the transformations here? X plus 3 meaning to the left 3, and plus 2 is up 2. So let's do that. Left 3, 1, 2, 3, up 2. So you're gonna have your graph here, something like this. So meaning the inverse of this part of the parabola, this green here, is this graph. So now let's define the domain and range of our f and the inverse. So domain of our f, so this is our f, is, so remember this is from 2, so that is from 2 to positive infinity. So meaning, since you are switching x and y, remember from one of the sections that we discussed, meaning the range of the inverse is also from 2 to positive infinity. Now, what's going to be the domain of f? Equals to the range of the inverse, we already answered that, which is from 2 to positive infinity. Okay. All right, next quick check. Find the inverse of the function f of x equal to x squared minus 1 and use a domain x greater than or equal to 0. So first, let's switch x and y. But first, this is y equals x squared plus 1. Switch x and y. Solve for y. Subtract 1. And then square root both sides. So that's going to be y inverse is square root of x minus 1. So this is the inverse when x is greater than or equal to 0. So it's like if you want to graph the x squared plus 1 is this part here of the graph. Parabola greater than or equal to 0 is this parabola, not the whole parabola. So it's just from 0 and above. And then the graph of the inverse, square root of x minus 1, that is 1 to the right. So starting here is this. So those are the graphs of the given function and its inverse. Now, what is the domain? The domain of f is from, yes, since it's given here, greater than or equal to 0 or from 0 to infinity, and the range of the inverse is, yes, the same, 0 to infinity. Okay, next, example 3. Restrict the domain and then find the inverse of the function f of x equal to square root of x minus 4. I'm gonna rewrite that here. F of x is y equals square root of x minus 4. Switch x and y. X is equal to square root of y minus 4. And then we square both sides to get rid of the square root. I'm gonna write it here. So that is x squared is equal to y minus 4. And then we just have to add 4 both sides, so that the inverse is x squared plus 4. And that is the graphical view of this. Square root of x minus 4, that's 4 to the right. So this is your f of x, and the inverse is x squared plus 4 is this part. Since square root of x plus 4 is just a positive side, so we only want from 0 and above, restricting the domain of our inverse x squared plus 4. So this graph here. So we can say that the domain, we know that always the domain of f is equal to the domain of the f inverse. Sorry, why do I always write that? Is the range of the f inverse. So what is the domain of f? That is from, yes, from 4 to positive infinity. So that is the same thing here, from 4 to positive infinity. How about the range of f meaning this is gonna be the same thing as, yes, your guess is right, the domain of the inverse. So now let's take a look at the range of our function f of x. The range of this blue graph here is, yes, from 0 to positive infinity. So that is the same thing as the domain of this is from 0 to positive infinity. Okay. Next one, applications of radical functions. Radical functions show up in physical models like Einstein's famous equation or the Pythagorean theorem. Example 4, a mound of gravel is in the shape of a cone with a height equal to twice its radius. So meaning the height is equal to twice its radius, given that the volume of a right circular cone is given by this formula: 1/3 pi r squared h. So since we have a value of h which is equal to 2r, and now we can substitute that to the h here. So I'm just gonna write v equals 1/3 of pi r squared times 2r. So meaning rv is equal to, if we simplify this, 1/3 times 2 is 2/3, pi r squared times r is r cubed. A shape of a cone, amount of gravel, so it's like this, something like that. Okay, so find the inverse, that is what we want. Oops, sorry. Find the inverse of the function so that r of v, then use the inverse function to calculate the radius r of such an amount of gravel measuring 100 cubic feet. Okay, so how do we find the inverse? So we have r and v, so we switch r and v. So that's what we do. So now this is r equals 2/3 pi v cube, and then solve for v. Okay, so get rid of 2/3, we multiply both sides by the reciprocal, 3/2. So that is 3 over 2r equals pi v cubed, and then we divide both sides by pi. So that is going to be 3r over 2 pi is equal to v cubed. And last step to get rid of cube is we cube root both sides. Okay, I'm going to write the answer here. So the inverse of that volume is cube root of 3r over 2 pi. Now to answer the last question, calculate the radius of such an amount of gravel measuring 100 cubic feet. So, if you go back to the original volume, which is to solve for the radius, that's going to be the radius is equal to cube root of 3v over 2 pi. And now you have a given volume, which is 100 cubic feet. So that's going to be cube root of 3 times 100 over 2 pi, and use your calculator, and it's going to be, the radius is approximately equal to 3.63. Okay, and that's it. Let's try now to solve some of the lecture questions. So these questions are from your OpenStax skills practice. First, let's practice finding the inverse of the given function f of x equal to 4 minus 2x cubed. So first, rewrite this as y equals 4 minus 2x cubed. And then switch x and y. X is equal to 4 minus 2y cubed. And then solve for y. So isolate y. So we do subtract 4. So this is x minus 4 is equal to negative 2y cubed. And then divide both sides by negative 2. Sorry, I don't have a space. X minus 4 over negative 2 is equal to y cubed. To get rid of cube, last step is cube root. So the inverse is cube root of x minus 4 over negative 2. Okay. Next one, number 12. For the following exercise, find the inverse of the function on the given domain f of x equal to 2x squared plus 4, domain from 0 to positive infinity. So if we try to graph this, I'm going to use here, it's a parabola, but 2x squared plus 4, meaning plus 4 is you go up 4. And since it is a parabola, like you have a stretch factor of 2, so vertically stretch something like this. But since we want from 0 to positive infinity, so we don't have this. So this is only the part of that parabola. Okay, so now let's solve for the inverse. So this is y equals 2x squared plus 4. Switch x and y. X is equal to 2y squared plus 4, and then solve for y. So subtract 4, then divide by 2, and then to get rid of square is square root both sides, so that you have the inverse, just the positive side of that, since we want from 0 to positive infinity. So meaning the positive numbers, x minus 4 over 2. And if we graph this, this is 1/2 of x minus 4. X minus 4 meaning 4 to the right. So this is the inverse of this green parabola. Okay, all right. Next and the last problem. Answer the following application problem. The volume V of a sphere in terms of its radius is given by V of r is equal to 4/3 of pi r cubed. Express r as a function of V and find the radius of the sphere with a volume of 200 cubic feet. So I'm gonna rewrite here the given volume, which is equal to 4/3 of pi r cubed. So we want to get the inverse of this. I don't think we need to solve for we don't need to find the inverse, since we just want to find the radius, and we already have the volume of 200 cubic feet. So let's isolate r. So what do we do here? Multiply by the reciprocal of 4/3, so that is 3/4. So this is 3/4 V is equal to pi r cubed. Then divide both sides by pi. So r cubed is 3v over pi, and then cube root, so that your r is equal to cube root of 3v over 3/4 of v over pi, or it's the same thing as 3v over 4 pi. Okay, and then we have a given of volume, which is equal to 200 cubic feet. So let's substitute that. R is equal to cube root of 3 times 200 over 4 pi. And here, use your calculator, and you will get approximately equal to 7.782 feet. Okay, and that's it for section 3.8. Thank you.